औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अल्लाहुम्मा अफ़्तह अलीना हिकमतका वअन्शुर अलीना रहमतका या ज़ल जलाली वल इकराम अल्लाहुम्मा इन्नी असअलुका इल्मन नाफ़िअन व अमलन मुतक़ब्बलन व रिज़्क़न तय्यिबा अल्लाहुम्मा आफ़िनी फ़ी बदनी अल्लाहुम्मा आफ़िनी फ़ी समई अल्लाहुम्मा आफ़िनी फ़ी बसरी ला इलाहा इल्ला अंता सुब्हानका इन्नी कुन्तु मिनज़ ज़ालिमीन. Assalamu alaikum everyone. Okay, today we are going to learn logic gates computer science 2210 problem statement. Means that with the help of these problem statement we have to extract our data, means logical statements, boolean algebra, to design later on a logic circuit. It's very easy process. So we are going to take start from example number 6. So let's take a start. Okay, now in example number 6 it's mentioned over here, a safety system uses 3 inputs to a logic circuit. A logic circuit having 3 inputs. See, this is our first point to extract the figure out number of inputs. So 3 inputs are there, means we are able to generate the possible combination. I will put this into 2 raised to power n formula to get the possible combination for the truth table. So in this case we will get 8 possible combination. And alarm X, you will get this output in the form of alarm X sounds if conditional statement, if sound will alarm if it follow this criteria. If is a conditional statement. If input A represent on mean you will apply 1, A is equal to 1, and is what? AND gate. Second input of AND gate will come from input B represent off. B is equal to off mean B is 0. Then after that here is OR, another criteria. OR mean OR gate. If input B represent on, B is equal to 1, and input C represent off, C is equal to 0. Till here any confusion?
No, sir.
Okay, after this, using this criteria we have to produce a logic circuit and truth table. We use truth table to check the behavior of the circuit, to check the outcome of the circuit, okay? Step by step, and produce logic circuit. And logic circuit is a combination of different logic gates: OR gate, NOR gate, AND gate, XOR gate, blah blah. Okay, to show the condition that cause the output X to be 1. The first thing to do is to write down the logic statement representing the scenario in this example. To do this, it is necessary to recall that on is equal to 1. I told you earlier that it's just like a switch. When you turn on the light, means that you are applying 1. When you turn off the light, you are applying 0. When you turn on the AC or fan, okay, ceiling fan, pedestal fan, AC, then you are applying 1. You are giving high voltage. When you are turning off with the help of remote control or manually you just press the button, you are applying 0. You are cutting off the electricity. You are applying 0 voltage to your circuit. And also that 0 is usually considered to be a not 1. Okay, not gate lage, not 1. 0 mean not gate. Okay, so let's move towards the next slide. Let's open this curtain. So I have explained this thoroughly to you guys. If you have a question regarding this problem statement, you can ask now. Otherwise we have to jump to the next part. Do you have any question, class? Yes or
No,
no? Let's jump to the next part. Whatever I have explained you earlier, now we are going to present over here in using PowerPoint slides. So let's start. First of all, first step is to figure out the number of inputs. So how many inputs are there? We are having how many inputs of this specific problem statement, or for this logic circuit we are using how many inputs? Please contribute. Speak louder, come on.
Three inputs है.
3 inputs. Please participate everyone. We are having 3 inputs is mentioned over here. There is no rocket science. A safety system uses 3 inputs. That's it to this logic circuit. So first of all we need to figure out number of possible outcomes or number of possible combination for the truth table. So we use the formula 2 raised to power n. Why 2? Because we are using binary numbers. So this n means it indicates number of inputs. So we will put 2 raised to power n instead of n. Now we are going to put 3 inputs is mentioned over here, 3 inputs. So we will write here 3 is equal to 2 raised to power 3 is equal to what? We get 8. So we will make 8 possible combination. Till here any confusion or question?
No, sir.
Okay, next part is we have to extract our data. I've explained this earlier. A is equal to 1. So look here. If input A is represent on, so I have just mentioned here A is equal to 1. Means A is equal to 1. Any confusion at this step? On mean 1. And then here is the AND gate. I have just given a few spaces here and just put AND over here. This is AND gate, and then I have the second input of this AND gate comes from B. So B represent off. So B is equal to off means B is equal to 0. Clear? I'm just interpreting, translating this statement. If you have a question till here, you can ask regarding this specific statement. Amal, Maryam, Shahid. Say yes or no. If you have a question, please ask. Am I audible? Come on, guys.
Yes, sir. Visible.
Okay, then look here. The second part is R. So I have mentioned R over here, which is R gate. This R. If input B represent on, so look here. B is equal to on means B is equal to 1. And over here, I will just put and this over here. C is equal to off, represent off means C is equal to off, which is 0. So let's move towards the next step. So now what we have over here, we have extracted this data from this problem statement, and now we are going to write its logic expression. So it's very easy. A1 mean just put A, then write and gate. B0 mean or off mean not B. This is called logic expression. Off mean not B. B off mean not B, or B is equal to 0. So here is one logic statement. Now next part is OR gate. So I have just mentioned OR over here. Now B is equal to 1. So direct B, I will just mention here B. Simple B means that it is equal to 1. And after that we have this AND. So I just insert this AND gate over here. C is equal to off, or C is equal to 0 mean not C. This is our complete logic expression. Now you can produce easily logic circuit with the help of logic expression. Any question, class?
लॉजिक एक्सप्रेशन सर दोबारा एक्सप्लेन कर दें एक बार.
It's very easy. Look here. A is equal to 1. So instead of 1, you just need to mention here just simple A. This simple A indicates that A is equal to 1. This AND, just put AND over here in capital letters. You have to just write here AND, means indicates that you are going to apply AND gate here. The second input of this AND gate comes from here. B is equal to 0. B is equal to 0 means it's not gate. 0 indicates here we are going to apply here not gate, not B. So in logic statement we write here like not B. So second is OR gate, just simple OR gate we will mention over here, because now we are joining these two statements with the help of OR gate. So here is OR. So OR means OR gate. Second, B on or 1, just you need to mention here B here. Just write B. B indicates that we are applying 1. And after that this AND gate comes over here as it is. Second, 0 mean again not gate. Here we have mentioned B is equal to 0 mean not B. So here C is equal to 0 mean not C. Clear?
Yes, sir.
Yes, sir.
So let's move towards the next statement. Next step. Okay, logic expression is now extracted with the help of this problem statement. Now we have to design a logic circuit. So it's very easy. So first of all, we have to work on the first part. The part 1 is A is, look here, this straight wire is going into where it becomes the input of this AND gate. So very simple. So how you will identify that you have to apply AND gate over here? It's very easy to identify. You have to check the last character of this its name, which is D. So just draw capital D over here. So it has minimum 2 inputs. So one is come from A, directly A mean 1. The second one is come from B. It's not simple B, it's not B. So first we will take start from B and then put a NOT gate in front of B gate, okay, and then give provide this input over here, connect this with AND gate and just take out its one output over here. So this is part 1. The second is OR gate. So we will put here OR gate. This will directly join OR gate over here, okay. Now the second part, this one, second part is B. It's B means directly, it will directly go over here, directly join the gate, just like A is equal to 1. Now here B is equal to 1, B on, look here, B represent on, B is equal to 1, it directly join this AND gate. Now second one is not C, here is not B. Okay, तो क्या था? So it's just we have to put a NOT gate here. Okay, in front of C here we just put a NOT gate, and output of this NOT gate will join or connect with the input of AND gate. So if you have a question till here, you can ask. I have just translated these two parts, this logical statement and this logical statement. This is part 1. I have drawn his circuit over here, logical circuit, and part 2 is logical circuit is over here. Now the final part, final puzzle is we have to join the outcome of this AND gate and this AND gate with the OR gate. So here we have the final logic circuit of this problem statement. This is our logic expression and this is our final version of the logic gate. Here is part 1, join the OR gate, and part B, join over here like that, and here is your final outcome. Question: we have successfully produced our logic circuit with the help of the problem statement. Now if you have a question, you can ask. If you have any query Please, you can ask now, because after that we have to jump towards the example number 7. Amal, Mariam.
No, sir.
Good. Okay, now move towards the next part, which is our example 7, problem statement. Example 7. So our problem statement is this one. A wind turbine has a safety system which uses 3 inputs. Just like example number 6, we are having 3 inputs here, means we produce possible 8 combination to a logic circuit. A certain combination of condition result in an output x from the logic circuit being equal to 1. When the value of x is equal to 1, then the wind turbine is shut down. When x is equal to 1, the wind turbine shut down. The following table shows which parameter are being monitored and form the 3 inputs to the logic circuit. So this table is very important. You need this table to extract the data from the problem statement. So these are the problem statement. These are parameters: turbine speed, bearing temperature, wind velocity. So parameters means these are 3 inputs. So wind turbine speed represented by S, bearing temperature represented by T, and the wind velocity represented by W. We are using binary values. For example, S is equal to 0 means the turbine speed is less than or equal to 1000 rpm. What if S is equal to 1? Then turbine speed is greater than 1000 rpm, and so on. So let's move towards the next step. We use this table to extract our logic expression. So now we have this data, this table, and now here is our problem statement. Actually, this one is our problem statement. The output x will have a value of 1 if any of the following combination of condition occurs. Either turbine speed less than or equal to 1000 rpm. Look here, turbine speed. So turbine speed represented by S. So it's mentioned here less than or equal to 1000. So where is there is means S is equal to 0, means turbine speed is less than or equal to 1000 rpm, means that S is equal to 0. So we, instead of this whole statement, we just write here S is equal to 0, and then again AND gate. AND is there, means we have to apply AND gate. Now second input of AND gate come from bearing temperature, which is greater than 80 degrees Celsius. So bearing temperature is represented by in this table with the help of T. So it's greater than, bearing temperature is greater than 80. So bearing temperature is, it means T is equal to 1. Greater than, bearing temperature greater than 80 means T is equal to 1. So instead of writing this bearing temperature greater than 180 degrees, 80 degrees Celsius, we just put here T is equal to 1, and here S is equal to 0 and T is equal to 1. So we will extract our statement from here like that. So after this data we will move towards here. So are you able to see this R? R mean, so we have to check these criteria, these all 3 statements. So R mean OR gate. So now let's check the next criteria. Turbine speed is greater than 1000 rpm. Turbine speed is represented by S. Is greater than 1000 rpm mean, so here is turbine speed greater than 1000 rpm means S is equal to 1. So here instead of turbine speed greater than 1000 rpm, we just write here S is equal to 1 to make our life easy. While generating, later on we will use this data to generate our logic expression or the logic circuit. So after that S is equal to 1, AND gate, again AND gate, wind velocity. So now wind velocity represented by W. So W Let's say over here wind velocity is greater than 1000 rpm. So wind velocity is greater than 1000 rpm mean kph, it's kph. Okay, now so it's w is equal to 1. So here we have to apply w is equal to 1, s is equal to 1 and w is equal to 1, because 1 mean wind velocity greater than 120 kph. Okay, and then again after that we will add r gate. Now bearing temperature is less than equal to 80 degrees Celsius. So here bearing temperature is represented by T. So instead of this bearing temperature you need to write here T. So T, now we have to check the binary values of this T. So we will read that bearing temperature is less than equal to 80 degrees Celsius. So here we check binary values less than or equal to 80 degree mean 0. So we write here T is equal to 0. And what we have over here, it's AND gate. So we just write AND gate. So second input comes from the wind velocity. So wind velocity is W. So let's check the binary value of wind velocity. Now it's greater than 120 kph. So again we will check over here, wind velocity is greater than 120 kph means that W is equal to 1. So that's how you can reduce this or extract the data from this problem statement. So look here, using this table we have extracted this data. Stage 1, first thing to do is to convert each of three statements into a logic expression. Use the information given in the table using this information and three conditions. These are three conditions 1, 2 and 3. Okay, that we have discussed thoroughly in the previous slide, and find out how these three parameters st and w are linked. We usually look for the keywords and, or and not when converting actually statement into logic. We end up the following three logic expression. Look here, turbine speed is less than equal to 1000 and bearing temperature is greater than 180 means that not s mean logic expression s is equal to 0 mean not s, and t is equal to 1 mean just simple t. Then turbine speed is greater than 1000 rpm and wind velocity is, second problem statement is this one, greater than 120. S mean s is equal to 1 and w is equal to 1. Simple s and w indicates that s is 1 and w is 1. Not s means that s is equal to 0 here in this case. So now in bearing temperature less than or equal to 80 degrees Celsius and wind velocity is greater than 120 kph means that we will convert this statement into logic expression using this table just like that. Means not t means that bearing temperature is 0 at this state, its binary value is 0, because if you use this table you can take that bearing temperature is less than 80 degrees Celsius. So bearing temperature represented by T and it's less than or equal to 80 degree means that T is equal to 0. So T0 mean not T, and then and this and comes over here and as an AND gate. Wind velocity greater than 120 kph mean W is equal to 1. So now let's verify with the help of this table. Okay, they will provide you this table in your exam. Okay, now wind velocity greater than 120 kph. So let's check. Wind velocity is represented by W. So it's greater than 120 means that it is 1. So that's why it's only W mentioned over here. Any question regarding this specific example? If you have a question or query, you can ask now.
No, sir.
Beta, here you have to convert these statements into a logic circuit. Please do it now and then share with me. Then I will give you feedback, okay? Now do it. Convert this problem statement into a logic circuit and then later on create a truth table. If you have no question, then please implement this. Thank you, beta. If you like this video, please like and subscribe my channel. Stay tuned.